Now we will talk about the second order Runge Kutta method, which is modified on based on the Euler's method. Okay, so modified Euler's method, which is also second order Runge Kutta. And you know that this Runge Kutta series is based on the Taylor expansions. So the second order basically is truncated at the h squared part, yn plus 1. The form of the modified Euler's method is yn plus 1 equals yn plus hf xn yn plus h squared over 2 f prime xn yn. So this is the modified Euler's method general form. And let's exchange this f prime to be represented by f. So now let f prime xn yn will be equals to f xn plus 1 yn plus 1 minus xn yn divided by h. Okay, then we can replace this f prime back into our general form of the modified Euler's method. So, which gives us the yn plus 1 equals yn plus hf xn yn plus h squared over 2 times this fxn plus 1 yn plus 1 minus xn yn divided by h. And we can rearrange these equations to get our final general form of modified Euler's method, which is yn plus h over 2 f xn yn plus f xn plus 1 yn plus 1. Okay, so now you can get the general form of modified Euler's method, which is the second order Runge Kutta. And you notice that in order to get this next step by n plus 1, in order to get this increasement function, it's related to itself by n plus 1, so it's not possible to solve. Then how we solve it? We can use Euler's method here. We can use Euler's method to estimate this yn plus 1. Then we can solve these whole equations to get our increment function yn plus 1. Okay, so we need to evaluate or estimate yn plus 1 star using Euler's method. And you know that yn plus 1 star will be equals to yn plus hf xn yn. That is our Euler's method, right? And in general, for the modified Euler's method, so the truncation arrow, this method gives us the higher accuracy as compared to Euler's method, but it still have the local truncation arrow, which is O to the h third. For the Euler's method is on the order of h squared. For the second order Runge Kutta, this modified Euler's method is h to the third. Then the global arrow, which you will times by the overall step which is 1 over h. Then you get the global arrow is on the order of h squared. So that is the modified Euler's method. Okay,